Hello, I'm Paul Licamelli, and this video is first in a sequence of 4 demonstrating a new experimental spectral editing feature that I have built into Audacity based upon the source code for version 2.0.6. At this time, the latest released version is 2.0.5. That's what you're looking at now. I will use that version to demonstrate the problem in this first video. I will use my own version to demonstrate the solution in the following ones. Let's listen to this sound. This is Audacity! Oh no, there's an extraneous sound behind my voice, and a rather loud one. Can I repair this bit of audio using what 2.0.5 provides me? Well, I can, but it isn't quick, it isn't easy, and it isn't obvious. Let me change the view to spectrogram first. Well, that makes it easier to see just where the bad sound is, and I'll zoom in at that period of time. Now I can see that that ring happens at about 3 kHz. It looks like it's slightly below. But which tool should I reach for first to fix this? Well, you might think the graphic equalizer. But that's actually rather too blunt a tool for this job. You see, there is no slider exactly at 3 kHz. I could try taking the two nearest ones, above and below, and pulling them down as far as they go, and that's 20 decibels, which really isn't enough. I can tell that from the preview. Even if I did this, I can tell by looking that I've not really eliminated that ring. I can repeat it a few times, and I can hammer that thing out of existence, but now I've carved a very deep trench in my sound and probably changed its timbre unacceptably. No, let's try something else. If you've learned some more about Audacity, you might attempt this other version of the equalizer, which allows you to draw almost arbitrary curves. I'll flatten that out, and I can just define a few control points very close together and pull down this middle one right near 3 kHz. Now let's try it. That's much better, a much more precise effect, but you see, I'm still a little bit off. I could just try repeating this effect, and maybe that gets rid of the ring. Is there a better way to do that without the guesswork and without the repeated application of the effect? Well, let's look at this. The plot spectrum window. Notice there are 2 frequency numbers at the bottom. One changes continuously as I move my crosshair. The other one jumps discretely and tells me where the peaks are. There. That gives me a more precise reading of 2,882 Hz. The equalization interface that we saw, which allows us to draw curves, it's very general, more general than we need, and it doesn't really tell you, though, exactly where you are putting those points on the frequency axis. Instead, I could use the notch filter effect, which is not so general, but it gives me a more precise control. I can enter that 2882 number exactly here, but then I need to enter a width value, a Q factor. I know what that is intellectually, but I really don't know how to look at a spectrogram and translate that into a number. I'll just leave it at the default of 1 because I'm kind of lazy that way. That seemed to do it very nicely. It looks like I nailed that ring on the first try, but my work isn't done. There's still a click, and there's still an overtone of that ring up here with a similar decaying tail. Let me first try to treat that one by similar methods. I'll shrink the selection, I'll bring up this dialog again, and I'll discover that the peak is at 7695 Hz. Let's open up the notch filter and enter that number. Now listen. Well, it sounds like that is too wide of a notch filter after all, So let me undo that, and let me try it again, and let me change this Q factor thing to, I don't know, 3? Well, that seems a little more acceptable. The S sounds more like an S still. And that leaves just the click and a bit of a bounce, and there are ways to fix that without deleting it, which I would prefer to do if I could, but I've already talked enough, so let's just snip those in a hurry, and let's listen to the result. This is Audacity! Well, that seems like a tolerable cleanup. If I weren't explaining it to you, I wouldn't have wasted time on those false starts with equalization, but even so, you see, it's not too easy. I have to enter in some numbers, I have to look at a dialogue, I have to hold digits in my memory, I had to listen to intermediate results and undo and try again with a different width factor, and the result's not perfect. I seem to have created a click here, even as I fixed another click elsewhere, because when I applied that notch filter, a bit of phase shift happened in the passband frequencies, and the basic notch filter effect does nothing to mitigate that. So anyway, is there a better way I could have done all of this? Well, that's what the next videos are about.